Welcome back to the part two of the periodic table. We are looking at group 1 and 17, all right, especially a trend. So you can see that the reactive trend and the melting point, boiling point trend is opposite. Is it more reactive but decrease? Is it less reactive but increase? Melting point, boiling point increase. So for start, this you can know the FR and F. These are the element that we can find in group 1 and 17 at the bottom, at the top. These are the most reactive in their own group. And of course, we say the trend is opposite, reactivity trend and melting point, boiling point trend is opposite. That means it is the lowest melting point and boiling point in their own group. And of course, you can see they are vertically or opposite because one is a metal, one is non-metal. So they behave in opposite trend. So by knowing one of the F, you can recall the trend. All right. So let's go a bit deeper to understand why they become more reactive. Okay, this is more for the G3 combined science camp. So you can look at electronic structure, right? 2, 1, 2, 8, 1, 2, 8, 8, 1. So you can see here the valence electron as you go down the group is further and further away from the nucleus. Okay, so there is an attraction force in the protons that's positive and the electrons that's negative. So when this electron is further and further away, the force of attraction will weaker. So that's why it's easier to lose. All right, therefore, metals becomes more reactive down the group. But non-metal likes to gain electron to be stable. Therefore, the trend is opposite. Okay, but it's a similar way of explaining. Okay, but for group 17, there is uh another trend is that the color become darker. Of course, there's one unspoken trend here is that density always increase down the group, no matter whichever group we look at. Okay, so it's nothing very specific. Okay, so we need to know the group 17 color. So we can see here the diatomic. So you can see the yellow gas, the yellowish green, reddish brown, purple, and then finally the black solid. Right? And you can see it's gas here, gas. Okay, bromine is the only liquid. All the physical state is telling us that the melting point, boiling point actually increased right down the group. All right, I can see the diatomic, the F2, the Cl2, the Br2, the I2, right, 82. Now for iodine, even though we say they're purple solid, but uh, if in pharmacy, when there's water, there's iodine solution. All right, basically we are looking at okay, iodine is a covalent, so they can partially dissolve in water. So normally what we see is really brown solution, right? In most of the time. So why do we need to know the color? Because in group 17, we will talk about this reaction called displacement reaction, right? Displacement reaction. Okay, that means a more reactive, right? So for example, you got chlorine and Ki. So chlorine is an element, then as another group 17, the I here. So your chlorine want to kick out iodine. And if it's more reactive, it will be able to displace, right? See, the more reactive, then it's able to displace. And when that happens, you will see something. I mean, there is a reaction and there will be a change. So that's why when we talk about this solution here is initially your Ki. Okay, most of the solution are colorless. Color, okay, color solution Ki. Then later iodine is brown color. That is why we need to know the appearances because we'll be asked these type of questions. There will always be three ways of asking. That means are they the observation number one? That's why you need to know the physical appearance. Then you may ask to explain why this reaction happens. So you talk about why is it more reactive or less reactive? And of course, the last one you may be asked to write an equation. So if I put it the other way around, that means if I got iodine and potassium chloride, so it's not always, not every time there'll be a displacement. So it's always start with an element, iodine is the element, and want to displace another group 17 chlorine. But of course, it's less reactive, therefore there's no reaction. If he asks the explanation, of course, the observation will be no visible change. Right? If there's no reaction, means there's no visible change. Or you can say the solution remain colorless. And the reason we can say that because iodine is less reactive, right? Therefore, cannot displace chlorine from KCl. So the key word is if it's less reactive, then it cannot displace. So that is the main concept. Okay, it start with first the element. Okay, and normally we're talking about group 17, so we're comparing the two elements from group 17. All right, the element want to kick out another one from the compound, and it can only do so if it's more reactive. All right. And of course, last but not least, we talk about ionic equation. Okay, so what we do is that we have to start from a chemical equation. We split aqueous into ions, right? Because ions are free to move in the equal states. That is why they can conduct electricity. Okay, then we cancel the common ions, you see, and the left over will be the ionic equation. So what the ionic equation is telling us is that the more reactive one would have a higher tendency to form the ions. Right? That is always the case. Even if you look at reactivity series of the metals, we talk about the displacement reaction, you also will see this kind of pattern. So, but what most important is, okay, this is the part where students will have more difficulty in the periodic table. So you also will see more questions testing on the displacement reaction. So go and practice. Look at this video already, practice, and then see what's the thing you don't understand. Then look back at this video again. Hope this helps you and hope that this will make your learning of periodic table a little bit easier. All right. For the pure chem students, stay tuned for the part 3 when we talk about transition method. Thank you very much.